Okay, so let's continue now with the first lecture. So next, I will basically the idea is that I will introduce you a bit our course side and basically how you can use the website and what kind of information is around here. And we have a dedicated course environment where we use basically cloud computing to actually do the exercises and practice the things. So I will shortly introduce you these basic things that will become really familiar to you after a week or two. But in the beginning, it might take some time to actually kind of navigate around the stuff in the course. Did we actually have the recording on already? Yeah, good. Yeah, so this is basically the site. I think most of you have already been here. So you have some basic information about the schedule and so on. On the left side, this is really useful thing for you. So you can navigate around the course materials easily. And basically the idea is that every week we will add new material here. So under here, under lesson one, we will have now only the materials for this week, but the next week we will have the lesson two and so on. And there is some general info here, so just practicalities where we meet, who we are, how to contact us, and so on. Then we have a dedicated site for learning goals. So basically, each week we have certain goals and objectives that we want to understand. So from here, you can basically kind of take a look what those are for each week and basically then reflect after the practical sessions like, well, do I now kind of have a clue, an idea how what were the aims of each week. Something about grading, there was already a couple of questions about this. So indeed, for the first period, we are focusing on kind of introducing you to the basics of Python programming, so that you can actually use those skills and then start to apply them to, well, in my case, to GIS problems and solving GIS tasks, and with Dave, this geology stuff. And the grading for the first period is such that it will be basically based on the exercises and about the points that you receive from each exercise. So basically, you have 1 week time to kind of do the exercises for each week, and they will be graded. So each exercise have up to 20 points, and basically to be able to get grade 1 from one exercise, you need to have at least 10 points, so half of the points, and then it goes the up to grade 5 if you get most of the things solved and done. And during the practical sessions, you will get help from the assistant, so I really kind of encourage you to go there, especially if you don't have any earlier programming experience. If you have from some other language, for example, using R, so then you might be able to do those things yourself because especially for the first period, the things that we do are kind of introductory things. But anyway, so the grading will be based on the points that you receive from the exercises, and that's it. So there won't be any kind of exam in the end of the first period. And why I'm talking about the first period, so there are people who are enrolled for Geo-Python course, but the geographers they have basically only one course, which is all the GIS, and it's basically split into half. So we have 5 credit points for the first half, and you will gain that. And if you continue to take the whole of the GIS, so continue to the second period, then you will receive 10 points. And there we will have a final assignment, which is basically you will write a big piece of software yourself, and that will be graded, and the grade will be based on that. But for the first period, it's just about doing the practical exercises and doing them in time. Good. Yeah, there are some resources. So we have listed some good books that might be useful. to learn programming. There is a lot of materials available on the web. There is a lot of good, actually interactive teaching materials also, like Code Academy, software carpentry. So if you're interested in kind of, well, doing even more stuff and wanting to learn even more, there are possibilities to do that. And Code Academy is, for example, really excellent in that sense. And then there are a lot of tutorials around. Basically, when, for example, and I guess also Wokko and Dave, so whenever I have some problem that I don't immediately know how to solve with programming, I just Google it. And typically you find some examples and some people who have been thinking of the similar problem, and then that can actually get you going. So just using the internet is really good for getting information about stuff. Yeah, and then, well, that was the motivation. Then we have the lesson overview. So we went through the basic concepts, and the next thing now is the introduction to the basic usage of the cloud computing environment. So here we basically have information about how we will do the exercises and actually do the programming during this course. Yeah. Yeah, in here. So we will be doing programming with Jupyter notebooks and Jupyter Lab. So there are many different kind of programming environments that we can use. Last year we used something different. We used this kind of development environment called Spider. This year we are doing something different using the kind of online based Jupyter Lab. I will show you how that works. So basically the programming is done in a browser basically. I'm sure that there might be some of you who are actually interested not using the browser based programming environment, but you want to install it to your own computer, and that is totally okay. We have instructions here how to install the software to your own computer, but there is a kind of what we will be mostly using is probably the browser-based computing environment, which is fairly straightforward and easy to use. So that is what we use for doing the programming. Then we will be teaching you how to do version control and how to use it, how to use Git and GitHub for actually saving the work and modifying your codes. How many of you have heard of GitHub? Yeah, quite a few of you. How many of have actually used that ever? Well, a few. Okay, that's good. So that is really kind of good thing to learn. It's really powerful kind of place to share your code, share your own work, document your work, and so on. So you will learn how to do that. And it is actually kind of it is required for you to use that, because the computing environment that we use, it will be basically only a temporary environment up to 6 hours, and then everything that you have there on that cloud computer will be destroyed. So unless you actually save your stuff on GitHub, which is the permanent place for all the codes that you do, it will be gone. So that's kind of also a motivation to actually start using version control and so on. But you will learn more about that later when we go on and so in practice how these work. We will be communicating online using this kind of piece of software as well called Slack, which is pretty nice communication application. We use it all time in our digital geography lab, as we have many people and lots of stuff happening, so we can actually separate different projects to different channels so that the discussions stay in kind of logical places, which is good. And quite many of you have already signed up for the Slack, and that was good, and it's actually part of the exercise 1 that we will do. And then we have the voting and polling during the lectures that you already was using. So that should be fairly straightforward. Yep. What do we have? So yeah. So basically, there will be. Can you see this? Yeah. Now this Mac stuff comes. I don't know how to zoom in. Well, there will be these kind of buttons in the lecture materials and in the exercises. And there is launch Cse Notebook and launch Spider, and I can actually just go here to taste of Python. Yeah, well, yeah, there is 3 buttons. And they are basically ways to actually open up the programming environment. So it's really, really easy. Maybe Dave, what is student binder and what is full binder? I guess full binder is basically for the lesson materials with all the stuff. Or
that works. Okay. Yeah. So the full binder, if you go to look at one of these lessons, like if Hendrik scrolls down here, in the lessons there are these little Python snippets that have produced some output. If you launch the full binder, it will be the version of this Jupyter notebook that has all of the output already there. So if I think our preference would be that when you're here in class, you should use the student version of binder, because what we'll do is we'll go through in class these lessons where you can be typing things in along the way. And so in the student version, basically all of the Python places where you could type something in are empty, and so you can fill those in as you go. If you're wanting just to kind of go back and see how something worked in an earlier lesson, you can use the full version of the binder that will already have all the output and everything there. It will, I think, become quite clear once you start using it, and we'll get our first experience with binder and Python later this morning.
Yeah. Yeah, so basically it takes a few minutes, well, maybe a couple of minutes. It depends a bit like how many users they are actually using this binder, like how long does it take, but typically it takes up to 1 minute to launch that stuff. So you can imagine as actually booting your computer. So it actually takes a while to get it running, but it should be there, and then everything should work. So yeah, so these kind of things are what we are going to use during the course. Then we have another one, which is the Cse Notebook. So we have option. Basically, this binder is kind of a global cloud computing environment, which can be used by thousands and thousands of people all over the world. So there might be a situation that it gets just crowded and it just kind of doesn't launch or something like that. So we have the possibility to use the Cse notebooks, which is similar one. You need to use the Haka authentication to actually get in, but it works in a similar manner. And for the AutoGIS part, we will be using mostly that Cse one, because we have some extra packages that needs to be installed and so on. So that's the way we do things. Yeah, maybe communicating with Slack. So how did I do the right click again? No.
2 fingers.
2 fingers. Yes. So can you log in?
The Slack app open if you want.
Yeah, well, if you have that one. So the next, yes. So the next thing that I want to share you is the Slack. So here we have had some discussions with Dave and Vuokko, but this is basically the Slack what we will be using. So it's really easy to use. We have separate channels on the left here that you should be able to see. If not, you can basically, I think, or we might need to kind of share those with you, but you should be able to see them. So we have channels for each week, and what we want you to do is basically we have the first lecture So if you have any questions or any comments or anything that you want to share, this is the place to share your thoughts. So this is just like messaging in any chat, and it should be straightforward. What there are some functionalities that might be useful for you is for example to and what did it do now? Okay, it went to some other workspace.
On the left side, you can click it far left. It's the lowest one.
This one. So if you put at, which is probably not there. Come on.
So this is the Finnish person using Finnish keyboard.
Yeah. How do I put the at sign here?
PC person using the Mac.
Yeah, this is a PC
fine.
person using a Mac.
It's option. Option instead of alt.
Yeah. These Mac people, I don't really understand. Yeah. So, but now back in the game, we had the same thing last year, but after a couple of weeks, I actually started to learn how to use Mac. But anyway, so if you put at and then basically, for example, I have a question for Dave, so I can say that at Dave and ask your question, and basically then Dave will be notified that okay, someone is asking a question from him. Also,
Asking myself.
yeah. Well, you know, it's the place for you to share your thoughts. Yeah. Also, one thing that we would like you to try to do is that if you have a question, so what we will especially do ourselves is that we will open up a thread. So if there is a question about something, so we want to keep things kind of structured, and if you put your mouse on top of here, you have certain kind of things popping up here. You can add a reaction like okay, that is cool, and so on. But maybe the more important thing is that you can start a thread. So under this first comment here, I can add another one. And basically, if there are one question and there are also other people like wanting to share or kind of answer also to that one, we really encourage you to use threads so things keep more structured in the discussion, and it's easier to follow and so on. And we really encourage every one of you, so we will be there answering to your questions, but it has been like that in all of the years that actually I hope there will be kind of a group communication and you can actually help your friend or answer yourself in here. So if there's a question and there doesn't seem to be answer coming from us if we're busy somewhere or something, so we please, if you know how to help, so you can just write yourself comments here and so on. You can also kind of write pieces of code in here with certain stuff, so kind of just showing. So there is what is this character here, but kind of a backtick. Okay, backtick. So with backtick you can basically kind of format your stuff in a way that it shows like a piece of code. But that's maybe the most important stuffs in here.
Yeah, I think the thing that we found most useful, I think both as instructors and for the students last year, was when questions were asked in Slack, that everyone could see the question and all of the responses, and so it was kind of like a good place to go and look if you're having a problem with the exercises to see whether someone has already asked a question in Slack that might be related to that. And oftentimes
they are.
There were good like questions that came up right away, and so you could find the common issues there.
Yeah.
From the start.
So indeed, if you're kind of struggling with something, we ask you to first come to Slack, see if there's something about the problem that you are facing, and only then basically start asking about it. The first motivation for this was that we didn't want to have a situation where we have 80 students sending us emails and asking basically the same question. So this is kind of a way to try to avoid that one. And there is a good search functionality. So if you have a problem that you are facing for, I don't know, whatever that might be, so you can use the search button, and it's actually quite powerful. It will go through the whole workspace, so all the channels, and find pieces of information that might be relative for you. So that's also a good thing to know. Has everyone actually managed to get into the Slack, or is there someone who still haven't been here and haven't seen this one? There are a few. Okay. No worries. Basically, the idea of the first exercise is that you should do that, so you will see how logging in works and so on.
You should have received an invitation from
Yeah.
the instructions. If you haven't, you can talk.
And there should be. Is there an invitation on the main side? No. Because there was some students, there were problems in actually receiving any email. So if you haven't received email from me or from Dave, please send us an email maybe. Let's go the old way so we can actually share the invitation link. And that is the last time we send emails, or yeah, so let's agree on that one. Yeah. Good. Are there any questions about using Slack or anything at this point? Or about anything really? If not, is there something else? I think we are more or less, we will go through now as Dave starts to teach you stuff, like we will actually do some programming today, not only talking. So you will see how the Jupyter Lab works and so on. So should we maybe then kind of proceed to the first program? Yeah.
Okay, so let's now continue, and for those of you who have a laptop with you and in front of you, if you're on the course webpage, you can go to this A Taste of Python section here of lesson 1. And I think the recommendation is going to be that that we try this with Binder first. And so what we want to do is open up one of these Jupyter notebooks that Hendrik had mentioned, and you can follow along as we go through the lesson and see what, basically how the Jupyter notebooks work, as we learn just a very quick bit of introductory Python stuff. So for that, I would suggest using this launch student binder, and we'll see how that goes. Binder is a free service, and so occasionally if it gets overwhelmed with like 60 or more people trying to launch at the same time, it may fail under that load, and we may try using the CSC. But if you click on this launch student binder button, I'm going to do the same thing so that we all have the kind of same experience. And actually, I may have one open here already, but I'll close this. And oops, yeah, that one already died. Okay, so I'm going to click on this launch student binder. And if you have any problems, if for some reason you do that and it doesn't work or whatever, perhaps you can get the attention of Volko or Lotta or the other assistants, and we can try to help. But when you click on the binder link, as Henka said, it's normally about 30 seconds to a minute before it pops up. If all goes well, you should get a screen that looks like this. And if you're having problems, if that screen is not showing up, if you're getting error messages or whatever, please let us know. Maybe raise your hand or something like that.
Yeah, and actually one thing that we maybe didn't mention yet, but indeed what we will do during the lectures is that we will do hands-on programming. So most of you already have computers which you, so that's really good. But if you don't have, so the kind of how you get full out of these lectures is that you would bring the computer and kind of follow up with the stuff that we do.
Yeah. And don't worry, because we're only going to do just a very short lesson on programming in Python today, so you won't miss too much if you just follow along watching for our purposes today. But is anybody having problems with Binder, or is it safe to proceed? I guess if everybody is kind of at this stage, the first thing we need to do is, unfortunately, Binder recently broke something that had been working before that would have just opened this notebook right away. For us, we need to navigate to where this notebook file is stored. And so over on the left, there's this file browser. Hopefully you see that. Let me see, maybe if I zoom in to something like this, that makes it a bit easier. So over here on the left side, there's a file browser. And if you double click on L1, and then that'll take you to the place where you should see this A Taste of Python file. And if you double click that, it will open it up here on the right side in this software called Jupyter Lab. This is a Jupyter Notebook document, and we'll explain a little bit about what that is as we go along here in just a second. But again, if you're having issues, we have help here, so just raise your hand and we'd be happy to help you. If I don't see hands up, then I'm just going to assume everything is okay and continue. So it's kind of up to you to make sure that you get the help you need. But for our purposes today, we're just going to get started with something fairly simple. And we're already in the Jupyter environment. And if you scroll down to the section that's titled Variables, Arithmetic, and Modules, that's where we're going to start. And we'll go down here to this section about simple Python math. And with an example here, we can just show you that, one, how you can use Python as a simple calculator, but also how Jupyter Notebooks work. So there's these text blocks in here where you can see the kind of lesson materials, and then there's these other cells in here where there's nothing right now, like where I've clicked the cursor. This is a Python cell in a Jupyter Notebook. In a Python cell, you can type in Python code and execute it, and it will display the output from that Python code in the notebook document. There are other cells here where we have some other text, and we can edit one of those as an example in a moment. But for instance, here, if you type in 2 plus 2, you can then press Shift-Enter to execute the Python code in that cell. And when you do that, you should see, for instance, the number 4 displayed. So all it did is just calculate what 2 plus 2 is and display the value beneath it. You could also multiply things, so you could do like 3 times 12 or whatever. And you can do Shift-Enter to execute the cell, or if you go up to the top, if you're kind of a mouse-based person, you can click the play button up at the top. That will also execute the cell. It does the same thing. I'm pretty keyboard focused, so I almost never will go click this thing. But that will run the cell, and again, 3 times 12 is 36, and you see the output displayed there. If you said, oh, I didn't mean 3 times 12, I meant 3 times 13, you can always go back and edit the cells where you've typed something in, and do Shift-Enter again to recalculate what's in there. So it's just the same as kind of like editing a document that has Python code in it, that you can edit what's in these cells. And the key thing is you press Shift-Enter to get it to execute the cell. Over on the left side, you can then see the order in which things were calculated. So you can see there's this 1 in the square brackets here. That's the first calculation that was done. And then it jumps to 3 here because 2 was recalculated in the same cell, so the number was increased to 3. So that tells you the kind of order in which things are executed. You don't necessarily need to go in the order of the cells in one of these documents, but that's probably a good thing to do just to avoid confusion.
On Windows computers, you can also use Control-Enter, which is the same thing as Shift Enter.
Okay. Yeah, that's good to note. The other thing here is that if you wanted to add another cell into one of these documents, you can click the little plus up at the top, and that will add a cell below. So if you wanted to add one more thing, say like, hey, I really want to do division, you could then do 10 divided by 2 and hit Shift Enter, and you get 5 as you expect. So that's how these Jupyter notebooks work. It'll take a little bit of time maybe to get used to doing this, and along the way we'll kind of explain why we've chosen to teach the course this way. It's different than we've done it in years past, but in part it's really nice that you can mix nicely formatted text with Python code so that you can have a nice description of what you're doing and then your code right in there in the same document. So yeah, let's go down here a little bit to the section on functions. And again, if there are questions, please don't feel like you can't interrupt us. We're very happy to drop what we're talking about mid-sentence and answer questions. So if things come up, let us know. But if we go to functions, for instance, we could do one example of something that we've already seen. So we could print. And if you type print and then parentheses, you could put in 2 plus 2. And this won't really do anything mind-blowing. But when you run that, of course, you get 4 out as you expect. If you were to put this 2 plus 2 in quotation marks, Python will interpret that not as adding numbers together, but just literally print out the text 2 plus 2. And if you run that cell again with that 2 plus 2, in that case, it just prints out those characters 2 plus 2. Now, if we go to the cell below and say, like, let's do something like calculate the sine of something close to pi, I don't know, 3.14, we'll just leave it at that. So sine is just a function, and if I hit enter, or shift enter rather here, in this case I get something called a name error. And perhaps it's a little bit distressing to think that Python can't calculate the sine of pi, but we'll come back to this in just a second. This is actually, there is a sine function in Python, but it's not something that's available by default. We need to tell Python to load in some math libraries in order to be able to do this. Okay so far? I'm not getting any kind of clear indications of that, like, yes, I assume that there's no protesting that things are going all right. So in terms of math operations, everything we can do for simple math in Python is shown here in the table in that section on math operations. So adding things together is with a plus, subtractions with a minus, star for multiplication, slash for division. And one thing that's maybe a little bit different from Excel, or I think it's also different from MATLAB, is to use the 2 stars for raising things to a power. We're doing I can never say this even in English, exponentiation. Raising things to a power is with a double star in Python. That's a little bit weird. It's not like the caret that you see in many other programming languages, that little kind of hat-shaped thing. So if we want to do things more advanced than just this basic arithmetic, we need to load in a module or a library in Python. So we can import something that will allow us to do math by typing in import and then math. What this tells Python to do is load in the functions that can be used to calculate math. So if I do import math and shift enter, it doesn't display anything, but it has done something for us. So that now if I do math.sine of 3.14, I won't expect that you know what the value of sine of pi is, but it should give us something close to 0. And if I hit shift enter, indeed I get something that's pretty close to to 0. Now I haven't put in the value of sine exactly, so I don't get 0 as I might expect, but something that's close. So what we've done here differently is we still used a function called sine to calculate the sine value, but we've said that sine function is part of a set of functions that are part of the math library. So by typing math.sine, after we've done this import math, we're using a sine function that comes from the math library. By default, there's things like print and this kind of basic math stuff that are available in Python, but it doesn't load much because it says the efficiency is important, and so only if you tell me to load some functions in will Python then be able to use it. But you could also do something now like math.square root, so SQRT, and you can pick your favorite number that has a nice, or maybe not so nice, natural square root. But if you do square root of 121, you should get 11, and indeed that is the case. So again, it's math.something to use a function out of a library or out of a module. And we will get some experience with this as we go through the course. We're just getting our feet wet today, and we will get more into loading modules, using modules, and even writing our own functions as we go later on in the course. And you can see a little bit of a description here about this, what we've had happening here. So we've loaded in the module, in this case called math, and then we use module name dot the name of some function to calculate something like the sine. So math.sine, as we saw, or math.sqrt. And there's also things that are part of these libraries, like the value of pi is stored in the math module. So math.pi, if you just type in math.pi and do shift enter, it will give you now a more precise representation of the value of pi. So in this case, 3.141592, blah, blah, blah. As you imagine then, if you do math.sine of math.pi, we now have a much better representation of the value of pi. So when we calculate the sine of pi, we should get much closer to the exact answer of 0. And when I run this, now I get 1.22 times 10 to the minus 16. So it's not exactly 0, and we could go into a rather long-winded explanation of why it's not exactly 0, but it's very close. Something times 10 to the minus 16 is pretty close to 0 in most of our daily experiences. So you can see here that indeed the representation of pi in Python does give us the sign of that value that's very close to 0. So you can also see here that we can put together combinations of things like math.pi, which is that's the representation of some number, and then a function here, the sine function, to calculate the value of pi, like this. In fact, in the section on combining functions, we can do another example here. So if we wanted to use the print function, we can do print, and then we can add something in there like, I don't know, math.tangent of, let's do math.pi over 4. I think that'll be a nice value. I don't remember exactly. So you got to pay a little bit of attention with the parentheses here. We're using the print statement, and we're calculating the tangent of pi over 4. Actually, that might not be a nice value, but and then we're putting this all inside a print statement. If I run that, I get a value that's quite close to 1 in this case. So yeah, indeed, that is a decent choice to use pi over 4. But here we've taken some value, we've had a function to calculate what the tangent of pi over 4 is, and then we've used the print statement to print that out. So you can kind of nest these things within one another. There's reasons why you don't want to do that too much, but you know, things like print are useful because you can say have some some text inside there
to say, for instance, the value of pi at, the value of the sine function at pi is, and then comma, math dot sine of math dot pi. So I hope I'm not typing too quickly. But here we can add some text. The value of the sine function at pi is, so that's all in quotation marks, and then there's a comma, and then math.sine of math.pi is where we calculate the value of the sine of pi. And when I print that out, I now see the value of the sine function at pi is this 1.22 times 10 to the minus 16 that we saw before. So that's one example of why you might like to combine functions. Is here, the print function can be used to write some nice text out, and then we can use another function to calculate a value. In fact, you'll more than likely end up doing this in some of the exercises where you will be asked to print out some value that you've calculated, and often you're going to want to have some text that goes with that to either specify the units for the value, or to just basically explain what this number is and not just print it out to the line all by itself. So yeah, how's the typing speed? Is this okay? Are you able to keep up so far? People complained last year, and I thought the Finnish keyboard will slow me down a little bit, but if I get going too fast, please don't hesitate to say something. Now, if we go to the section on variables, these are going to be kind of a fundamental part of what we do in Python. And a variable is just a way to store the value of something in a name that's useful to us. So, for instance, if we had a temperature and it was in Celsius, I could type something like temp underscore Celsius equals 10.0. And when I run this cell, it doesn't display any output, but it stores the value 10 in the name temp Celsius. So that if I then go print temp underscore Celsius, and I run this cell, then it prints back the value 10. This is not something that is uncommon to programming languages. This is sort of fundamental to name values in useful names, because we could have one number here, or we could have an array of thousands of numbers that we can refer to with a single name. The thing I want to point out here with this temp underscore Celsius is this is one of the kind of recommended ways in which you name your variables. It's called pothole case naming, where each part of the name is separated by an underscore. It makes for variables that are very easy to read, and we don't recommend necessarily that you use variables like T to represent temperature in Celsius when you could just type out temp underscore Celsius to represent the name. So if I added another cell here, I could say, TF equals 32, and then you'd be, if you're looking at my code, guessing what TF is meant to represent. And instead, if I wanted to be more helpful, I might say temp underscore Fahrenheit's a little nasty to spell, but temp underscore Fahrenheit equals 32. And this now is a variable name that's much more intuitive. And one of the things that you want to think about, not only for yourself, but for the possibility that you might share some of the code you write, is to use useful, intuitive names for your variables. Because even yourself, you might be shocked to find that after not looking at your code for 2 weeks or something, you come back and you can't remember what TF is supposed to mean. And that's really not where you want to lose time when you're trying to figure out how to get your code working, is to go like, what did I mean with this variable? And yeah. Anyway, at this point, we can do a quick check of your understanding. And so if you're here in your Jupyter notebook, we have an empty Python cell below. And all we want you to do at this point is just to define a variable. Could be anything you want.
and print its value to the screen using the print function. And you can put your bit of the code down here beneath this line that starts with the number sign. This is a way to indicate a comment in Python, or to basically tell Python to ignore anything that follows this number sign or pound sign. And so all you should do is just define a variable beneath that and then print the value of that variable out to the screen. So just take a second to see that you're able to do that and that you're following along with things so far, and then we'll continue from there. And if you're having problems with stuff, also just let us know, and we'll be happy to help sort your problems out.
Otherwise, it doesn't seem like everyone's kind of doing that without a problem like it is, or but we can ask about people a second. We can make a question update the question able to do that.
So how are we doing? Has everybody been able to define a variable? Yeah, and printing it out? Any problems? If you're having trouble defining a variable or printing it out to the screen, just let us know. And I can just give an example here in case we want another one. Let's see. How about cat name equals. Here I'm going to define a variable called cat name with the text nutmeg. So this is our former cat, and then I can do print my cat's name was, and then cat underscore name. So if I run this, I see the text, my cat's name was nutmeg. And so hopefully you've been able to do something similar to that. If at this stage I've decided that perhaps I want to qualify what I've done in my code here with a little bit of extra text that describes what's going on, perhaps I'd like to write Nutmeg's memoir here. I'm going to go, and if I click on this text that's above where this Python cell is, just to select it, I'm going to add another cell above this. So I'm going to click the plus here to add a cell above this one. Once you've added a cell, you can also click on them and drag them around. So if you added it beneath, you can always drag it up on top. But in this cell, rather than adding some Python code, since I want to put Nutmeg's memoirs here, I'm going to change the type of the cell from code to something else. So there are several different kinds of cells you can have in a Jupyter Notebook document. The two that you're most likely to use are code, which is where you can put your Python code, or Markdown, which is where you can put some text that describes other parts of the document. It might be where you answer questions to things that we've asked in the exercises or whatever. You'll get some experience with using Markdown already. I don't remember for the exercise this week if you do anything with Markdown. You could, but you'll get experience using Markdown as we go through the course. It is a language that is a very simple way to format text nicely, so it looks like plain text when you type it in, and then when you process it, it renders nice looking text. So I could add in here number signs. So one of them, they represent different sizes of the headings. So a single would be like the biggest heading, 2 number signs would be the kind of second level heading, and so on. And if I said that this is going to be Nutmeg's life story, and then beneath that I can start writing some text. In the year 2000, a tremendous cat named Nutmeg was born. And I could continue on with this story that may or may not put you to sleep. But basically the point here is that I can add in this kind of text, and maybe I would add just a little bit more just to give you a demonstration of how Markdown works, and I'll list a few of Nutmeg's life accomplishments. Excessive weight gain, let's see, making messes, and eating plants. So this already looks like decently formatted text that is relatively easy to read, but when I do Shift-Enter on a Markdown cell, it will convert that Markdown text into the kind of nicer looking formatted output. And so now, when I do Shift-Enter, I get Nutmeg's life story as this big heading here, some text, and then a nice bulleted list of Nutmeg's life accomplishments. So you, again, will get some experience with this. We're going to be mixing in these Markdown cells with Python regularly. And the important thing is that if you accidentally take a Python cell and convert it to Markdown, and then you try to run that, you will still get some output, but it might not be the output that you want. If you just double click on one of these Markdown cells, you can kind of bring it back to the stage where you can edit that and, for instance, change it back to code if what you meant was to have a code cell or things like that. And then once you've switched it back to code, you can then run and it works like you might expect. So don't panic if you don't understand everything about Jupyter Notebooks yet. You'll get experience with this and things will get more intuitive. But let's continue for the moment with updating variables. So we had earlier defined this variable temp_Celsius and given it a value of 10. Of course, we can take temp Celsius and give it a new value of 15, for instance. And if I run this cell, it will now define the value of temp Celsius to be 15, and I can print that temperature in Celsius is now temp_Celsius. So not a big surprise here when we run this that we get the new value we've just defined above in the output that's here. So one important thing about most of the variables that we'll deal with in Python is that they are able to be changed. So you can redefine their values and it just overwrites whatever was there. So we have no history that the value of temp Celsius was 10 in the past. We only know its current value. If I was to say, write another print statement, so print temperature in Fahrenheit is, and reference some variable we haven't defined yet, like temp capital F Fahrenheit. If I run this cell, I get a name error. And the name error basically refers back to the fact that there's nothing that has been defined with the name temp Fahrenheit yet. We don't have a variable called temp Fahrenheit, so when we try to print the value, it says I don't have that value and gives this name error, and even gives a somewhat intuitive message that says name temp Fahrenheit is not defined. So there's no variable called temp Fahrenheit. When we defined it earlier, we did temp_Fahrenheit. And so that's the reason is that we have to reference this with the exact same name we defined it with initially. So if we go down to these empty cells below, one of the things you can do in a Jupyter notebook that's kind of handy is we could define temp Fahrenheit to be equal to, I don't know, 32. If I define that value of temp Fahrenheit at this stage and run the cell, I can go back up to the cell I had used earlier where it gave me this name error, and if I run it again with the value of temp Fahrenheit now defined, I get the output that I expect. So this is where like the order that you list the things in the Jupyter notebook doesn't matter as much as the order in which you run the different cells. So if I ran this temperature in Fahrenheit before I defined its value, I get an error. Once I've defined the value, then I can go back and run the cell and there's no problem. Again, it's probably recommended that you don't define values later on in the file after they're supposed to be used, just because that's confusing, but you can do things like that.
Yeah.
Yeah, so basically this is something that you can do in Jupyter notebooks, and if you basically run things like cell by cell, this is okay. But this is actually not something that is really recommended, especially when, for example, in all the GIS part, so in the period 2, we'll be also doing scripts that are different than these notebooks. So actually the order how you define variables, so like even though this work now in here, if we would run all the cells, which is one possibility that we can do actually in Jupyter notebooks, so you can basically take the script and run everything, like all the Python cells that you have in here. So in that case, if we would do that, we would again be in a problem because we haven't defined the Fahrenheit variable in a way that it was written here before we actually tried to use that thing. So that's something that you should know.
Yeah. So if we go to this cell now where we've defined temp Fahrenheit as being equal to 32, we know that we can change the value of temp Fahrenheit, so let's do that. Actually, maybe I'll do it the other way around. Let's change temp Celsius. And say temp Celsius is equal to temp Fahrenheit minus 32. And I have to put this in parentheses now because of the order of the math operations. But if we take temp Fahrenheit minus 32 and then we multiply by 5 divided by 9, the very intuitive conversion between Fahrenheit and Celsius, we can calculate the temperature of Celsius that corresponds to 32 degrees Fahrenheit. And if I do that and run that cell, I can then print out something like print temp Fahrenheit is comma temp Fahrenheit, another comma, and temp Celsius is temp underscore Celsius. So it's a little bit longer thing to type in here, but we're just going to print out the temperature in Fahrenheit and the temperature in Celsius. And when I hit enter, I get temp Fahrenheit is 32 and temp Celsius is 0. And that is kind of what we would expect. If I go back up to the cell where I had defined temperature Fahrenheit before and change its value to maybe 70 degrees and run that, that will redefine the value for temp Fahrenheit. And if I run not the cell directly beneath it, but the one down here in the variable values section, so I'll scroll up a little bit to make that easier to see. When I run this, I see now temp Fahrenheit is 70 and temp Celsius is still 0. So this is important because if you're used to using spreadsheets where maybe you had some equation in there to convert between values, between some value in a cell that was representing, for instance, temperature in Fahrenheit, it would automatically update the value of temperature in Celsius when you can calculate, or when you change the value of temp Fahrenheit. In Python, the only way the variable's value gets updated is when you assign a new value to that variable. So we updated the value of temp Fahrenheit here. We can see that was thing number 27. Temp Celsius was executed before, and so its value was using the old number in temp Fahrenheit, which was 32. So 32 minus 32 times 5 over 9 would give us 0. And then here, when I did the print statement, I had the new value for temp Fahrenheit that was defined here, but still an old value for temp Celsius. So again, it's not a big thing now. You'll get more experience with this, but if you're used to how things operate in Excel, that, for instance, this would be a bit different. Now, the last thing we're going to talk about here in our Taste of Python lesson is a bit about data types. And this will be kind of a short little introduction to data types, but these are basically different kinds or different types of data that can be represented in Python. And if you see the table here, these are 4 basic data types that are already available in Python. So that includes integer values. So these are whole numbers, floating point values or decimal values called floats, and that would be any kind of a decimal number. str stands for string. It's a character string, which basically means text. So in this case, like the word hot is in quotation marks, that's a character string. And then these bool values, that stands for Boolean or true or false type values. So you can represent data as being either true or false. And there's a function in Python called type that will allow you to check what kind of data you have. So for instance, if we use type and temp Fahrenheit, what do you expect? Anybody willing to volunteer a guess for what kind of data type you expect here? So we got 1 vote for string. Anybody else want to? I couldn't quite hear the int. Okay, we got an int vote. We got at least 1 for float, and yeah, in this case it is a floating point number. Even though the value does seem to be a whole number, 70.0, because the decimal point is in there when it's defined, it stores that value as a floating point number, not as a whole integer. If we did define temp Fahrenheit as just equal to 70 with no decimal point, and I execute that cell and I go back and check what its data type is, now we do get that it's an integer. So if you include the decimal point in the number, even if it's 70.0, Python sees that as a floating point value. If you set it with equal to 70 with no decimal point afterwards, it then says, oh, that's a whole number. So that won't probably be a big problem for us in this course. In Python 2, could be a problem, but here we should be okay. But just to make the distinction that if you include the decimal point, then it will convert that as a whole number. And if, for instance, you said that it was temp Fahrenheit was 70 in quotation marks, what do you think now? What kind of data type would we have? String? Yeah, I kind of hear it quietly. But yeah, sure enough, it's a string. And it wouldn't make much sense to say temp Fahrenheit equals true, but there's nothing that prevents us from doing that. So if we set it equal to true or false with a capital T or capital F, then the data type now would be a Boolean data type. So the reason that the data types matter is because some kinds of data are compatible with one another and some kinds of data are not compatible with one another. So just as an example, if we go back to temp Fahrenheit and set it equal to 70.0 like it was before, and then of course we check the data type and see that it's a float. Floats are compatible with certain kinds of operations that make sense for a float. So if I said temp Fahrenheit divided by 5, I can take a floating point number and divide it by 5, no problem. And I get 14 degrees back for what that division is. If I had my temp Fahrenheit in quotation marks, and as we saw before, now it's a type string, what do you think is going to happen when I divide a string by 5? I'm going to get some kind of error. Syntax actually is okay in this case. We're typing things in like it is. It's not logical to do this, but it is okay in terms of the Python syntax to divide a variable by 5. Python doesn't know at the moment that this is a certain data type in terms of the syntax. But if I try to divide a number by 5, I get a type error, in this case saying that you can't divide a string by an integer. Python does not know how to divide character strings by numbers. It doesn't make any sense, and so hence you get this type error. So you will occasionally come into issues with data types that may or may not be compatible, so this is something just to have in mind. Python, in contrast to things like Fortran or C or a number of other compiled programming languages, Python automatically defines the type of data when you assign the values. You don't have to define the type of data in advance. So if you've done things in Fortran where you have to just say, like, define that this temp Fahrenheit is a floating point value or a real number, if we're talking about Fortran, then you can define it. Well, you don't have to do that in Python. That's automatic. So let's do one last thing here before we finish up. You can check your understanding here at this last little cell in the Jupyter Notebook, where you can define a variable that's equal to the result of dividing an integer by a floating point number, or vice versa. You can divide a floating point number by an integer. So store that value that you get in a variable and then check its type using the type function. And you can see whether or not you get what you expect. And you can also try testing this out by dividing two integer numbers and seeing what your resulting data types are. So is that clear kind of what to do? Just test it out and see what you get for your data types.
Is there anything that we've not mentioned that you could think of? Okay. Yes, we should quickly go through the exercise.
Yeah. Okay, we've got a couple minutes for that maybe. So, okay. So any problems so far? What kind of data types are you getting back when you do division in Python? Or does anybody have a data type that they got? Maybe we'll give you a minute to keep going here. So as we're running out of time here shortly, and we do want to have just a moment to introduce what the exercise is for this week, I will maybe interrupt you, and you're welcome to kind of continue to play around with data types and things like that in the Jupyter Notebook after we finish up. But here what I've done is I've said a variable called result equals 4 divided by 2. These are both integer values, and then the type of result. And when I run this, I get back that the data type is a float. As far as I know in Python, anytime you divide any number that makes sense with reasonable numbers, you always get back the data type float. And if any of you happen to have used Python 2 before, that was not the case in Python 2. You would get back, if you divided 2 integers, you often got back an integer result. And that was not necessarily good because it was very confusing and could introduce problems like dividing 3 by 2 would give you 1 instead of 1.5. So yeah, basically when you do division in Python now, you always get a floating point value back. Are there any questions about this introductory lesson, or maybe I'll turn it over to Hendricky and have an introduction to our exercise. Vocal's good.
What happens when you close the browser?
Ah, yes. So Vocal's asked a very good question here. If I close the browser and I'm using Binder, say bye-bye, everything's gone. When I relaunch Binder, I've lost everything I've typed in. So if you're using the Cse notebooks, that's not necessarily the case. When you close your browser, if you've connected and launched it using the Cse notebooks, you can reconnect to your existing.
Yeah, you have 6 hours of living time.
Yeah.
So that's the fact. But it's not there permanently either.
Yeah. The other thing to watch out with Binder is it times out after maybe 20 minutes or half an hour. And if you haven't done anything, it just closes your session. So Binder's good, it's fast, it's easy to launch and get it up quickly, but if you're going to be like wanting to continue working after you take your lunch break, I wouldn't leave your Binder session open and assume that you'll be able to come back to it, because more than likely it will be gone.
So maybe we actually show how to save stuff from there.
Yeah. So if you wanted to save the output from this notebook, for instance, I can go here to the file list, and if I right click, there's an option to download the file. So I can download this notebook if I want to come back to working on it or work on it on my own computer. If I want to upload it to GitHub or something like that, you can download here just by right clicking and then selecting download, and as you might imagine, it just then prompts me to save the file, and I get a copy of this notebook. You might think that you can save the file locally within here because you can make changes to the notebook and then save that. But again, since it's in Binder or if it's in the CSC system, you've saved it, but you've saved it on that cloud computer that disappears as soon as you close your web browser or as soon as you close your session with the CSC. So just be aware, we will, I don't know, beating it into your head is maybe not the right term, but we will strongly emphasize that you should never save your files in the Jupyter Notebook locally, unless you're working on your own computer.
Yeah, and especially for I will shortly explain about the exercise 1, but this is basically what you showed. So now was the thing that you should do. So we ask you to create some file, then you should actually download it to your own computer and then put it in the GitHub. We will next week, I think, basically show you how we will actually do that later on. So we will use Git to actually communicate between GitHub. But for the first week, this is how we do it.
Yeah. So here's just as another example. I just hit back, or in the web browser, I hit back and essentially told it to relaunch Binder. And now, if I go to my A Taste of Python notebook, no, everything's gone. So just be careful with Binder. That's you can accidentally close tabs, close windows, and have some unfortunate circumstances unless you listen to us and save your things regularly to GitHub. but we'll talk about that. But maybe just a quick introduction to the exercise.
Okay, so for the first week, you might have already taken a look at it, but we will always have an exercise kind of landing page here. And basically what we would like for you to do this week is pretty simple. So we're going to use, as we said, GitHub for a lot of stuff. So what we would like you to do is to actually go into GitHub site and basically create an account for you if you don't have that yet. If you have GitHub account, you can of course use that one and send us. So basically it's fairly easy to sign up for that one, so you need to enter some details and so on. And what we would like you to actually return to us is to basically on the first week channel in Slack to say your name and then basically your GitHub account, basically username, and then which course you were in. So then we can actually we do some stuff and with that information to actually keep track what you have done. So that's the first part, and then the second part is to really kind of use. We are using this kind of GitHub Classroom for distributing the exercises for you. So when you have the GitHub account, you can actually press this button, GitHub Classroom, and what that will do is that it will basically take our exercise and take a copy of that into your own personal GitHub account. So whenever you log into GitHub, you will always see all the exercises that you have done, and that is how we operate. And those exercises that you do, they will be private. So only us teachers and you yourself will be able to see those. So basically, like it's not open to the world. So that is how we do. And basically, there will be this kind of question about the classroom roster. So when we have your GitHub credentials on Slack, we will actually put those in here, and you can just click the name that is yours, so that we basically kind of can identify which of you are doing what.
Now you can even just press skip there and do that.
Yeah, now you can just skip for this week, because that's basically, well, we don't have those yet, so it's a big problem. And then the other thing, so when doing this exercise one, which I will do the skip. Then there is accept this assignment. So yes, I will accept and I want to have this assignment. So now I'm under with Dave's account here. So what it will do is that it will create a repository. If there is some starter code from us, so we actually are providing some piece of code in there that you should fill in or something, it will be done there. But basically it takes a few seconds, and then you will have this kind of repository under your own account. So now what we have here, as we're with Dave's account here, so we have Geo-Python 2018, and then we have exercise 1 Dave WIP. And this is how things will be done or will be organized in GitHub. So whenever you log in, you will see these kind of repositories for yourself. And here we have the exercise 1. So basically what we want you to do is to open a Jupyter Lab that you already did. So should be pretty straightforward. Then we want you to set up some variables and print out some stuff. So it's pretty straightforward. And then the last thing what we want you to do is to actually download the script to your own computer and basically just for this first week now, the only thing that you need to do is to drag and drop. So you open this exercise repository in GitHub that you're working on, and from your own computer basically drag and drop the information to GitHub, where it basically saves that permanently there. It asks you a commit message. This is something part of a version control. So you can just add there like my exercise 1 completed or something like that. And then press commit and it will be saved there. And that's basically what you need to do now. And if there are some problems, and this might be now for the first time as you're doing it a bit confusing, so really recommend you to come to the practical sessions that are on tomorrow and on Friday. So our assistants and we can actually help you out to sort out these things. It's pretty straightforward, but of course when doing things for the first time, it can be a bit confusing sometimes.